let us do the last problem, the sixth one. Find inverse Laplace of s divided by s power 4 plus 4a power 4. Now I'll take the function. Before splitting this by partial fractions, I'll try to rewrite the numerator in a simplest form and then try to split it as partial fractions. So I'll write this as s divided by, now the denominator is s power 4 plus 4a power 4. I'll try to write it as some a plus b the whole square minus some term. So I can write this as s square plus 2a square the whole square. If I expand this s square plus 2a square the whole square, I'll get s power 4 plus 4a power 4, and I'll get one more term extra, and the extra term is going to be 4s square a square. So what I'll do, I'll subtract that term. So minus 4s square a square. And next, I see that this is in the form of a squared minus b square. So I can write this as s divided by s square plus 2a square the whole square minus 2s a the whole square. A square minus b square. So a square minus b square can be written as a plus b into a minus b. I can write this as s divided by s square plus 2a square plus 2as a plus b into a minus b, s square plus 2a square minus 2as. Now I have simplified the denominator, after which now we will apply the partial fractions for this term. So s divided by s power 4 plus 4a power 4 is now equal to s divided by s square plus 2a square plus 2as into s square plus 2a square minus 2as, and the partial fractions for this is being written as as plus b divided by s square plus 2a square plus 2as plus cs plus d divided by s square plus 2a square minus 2as. So I have split this as partial fractions. Now the thing is, we need to find the constants a, b, c and d. What we'll do is, we need to take the LCM for this. So s equal to as plus b into s square plus 2a square minus 2as plus cs plus d into s square plus 2a square plus 2as. Now to get the value of the constants a, b, c and d, what we need to do is, we need to start comparing the coefficients on both sides. So before doing that, what I'll try to do is, I'll try to multiply all this and get the coefficient terms individually. So this is s is equal to as cube plus 2a square s capital A minus 2as square capital A plus bs square plus 2a square b minus 2as b plus, now multiplying these two terms, I will get cs cube plus 2a square sc plus 2as square c plus ds square plus 2a square d plus 2as d. So I've multiplied all the terms, and now I'll start comparing the coefficient of the s terms. The highest term is cubed, so I will first begin with the s cube term. equating coefficient of s cube on both sides. On the left side it is 0, on the right side it is capital A and plus capital C, and which will imply A is negative of C. Next I will compare coefficient of s square on both sides. Again we see on the left side the term is 0. On the right side it is minus 2a capital A plus, again the next term is b plus 2a c, and then the next is plus d. Now what I'll try to do, I'll try to substitute the values of c. I've got a as negative of c or c as negative of a, and I'll write this as 0 is equal to minus 2a capital A plus b, and c is negative of a, so I can write minus 2a capital A plus d. And so minus 4a capital A plus b plus d is equal to 0. So this is what I get when I compare the coefficient of s square on both sides. Next what I will do is, let me try to equate the coefficient of s on both sides. Equating coefficient of s on both sides. Equating the coefficient of s on both sides, I get 1 is equal to 2a square capital A minus 2a capital B plus 2a square capital C plus 2a capital D. So this is what I get. Next, lastly, I'll try to give the value of s as 0. If s is equal to 0, if I give s as 0, I'll get 0 is equal to b into 2a square plus d into 2a square, or I get 2a square into b plus d equal to 0, which implies b plus d equal to 0, and that implies b is negative of d. So I can substitute this b value here in this equation. If I substitute b as negative of d, what I get is, I'll mark this as 1. Substituting b equal to minus d in 1 will imply minus 4a capital A minus d plus d equal to 0. And so this implies minus 4a capital A equal to 0, and that implies a is equal to 0. If a equal to 0, we also see that a is negative of c, so c is also 0. So that will imply c is also equal to 0. So we get a and c as 0, and we shall try to find what is the value of b and d. We need to substitute the value of a and c as 0. Here let me name this as equation number 2. So I will try to substitute the values of a and c and get the value of b and d. So if I substitute b and d values, now I will get minus 2ab plus 2ad equal to 1. And I've got d as negative of b. So this should be written as minus 2ab minus 2ab equal to 1, or minus 4ab equal to 1, or b equal to minus 1 by 4a. If b is minus 1 by 4a, this should imply d is 1 by 4a, because d is negative of b. So we have found a, b, c and d values. A is 0, b is minus 1 by 4a, c is 0, d is 1 by 4a. We need to substitute all the values of a, b, c, d and find the inverse Laplace. So let us do that now. S divided by s power 4 plus 4a power 4 is equal to as plus b. A is 0. So I get b, which is minus 1 by 4a into 1 divided by s square plus 2as plus 2a square plus cs plus dc is 0, and so I get d is 1 by 4a into 1 by s square plus minus 2as plus 2a square. Now let me apply inverse Laplace on both sides. So inverse Laplace of s divided by s power 4 plus 4a power 4 is equal to minus 1 by 4a L inverse of 1 divided by s square plus 2as plus 2a square plus 1 by 4a times L inverse of 1 divided by s square minus 2as plus 2a square. Now if I see the denominator is a quadratic, I need to make it a perfect square. So I will rewrite this as minus 1 by 4a L inverse of 1 divided by s plus a the whole square minus a square plus 2a square plus 1 by 4a, doing the same for the next term, 1 divided by s minus a the whole square minus a square plus 2a square. So this will be equal to minus 1 by 4a L inverse of 1 by s plus a the whole square plus a square plus 1 by 4a L inverse of 1 by s minus a the whole square plus a square. So we see that this is equal to minus 1 by 4a e power minus at L inverse of 1 by s square plus a square plus 1 by 4a L inverse of 1 by s square plus a square. I forgot to write this e power at here. So this is equal to minus 1 by 4a e power minus at. This will be sin at by a, and this is e power at by 4a sin at by a. And so this can be written as sin at by 4a square e power at minus e power minus at. To bring it to the form of a hyperbolic function, I can also write this as sin at into e power at minus e power minus at by 2a by 2, and outside I can write 2a square. So this will be equal to sine 80 sine hyperbolic 80 divided by 2a square. So this completes the last problem, number 6.